Hello everyone, welcome to Module 9, Lesson 5 Variation. In this lesson we are going to learn how to recognize and solve direct and joint variation equations. And number 2, recognize and solve inverse and combined variation equations. Okay, so we start with number 1, direct variation and joint variation. We say that y varies directly with x. When we say y varies directly with x, then we can write y equal k times x, or y over x equal k. This form here is just another way to write y equal kx. You divide by x here, it becomes y over x equal k. Now, what do I mean by y varying directly as x or with x? This means that when x increases, y also increases. If x decreases, y also decreases. Now, the k here is called the constant of variation. Now, if I know that y varies directly as x, and we know one set of values, or let's say we know two set of values. For the first set of values, for x1 and y1, y1 varies directly as x1, so I can say y1 equal kx1, or y1 over x1 equal k, as we mentioned here. For the other set of values, I can also write that y2 over x2 equal k. You see here that this ratio equal to k, and this ratio is also equal to k. So therefore I can write y1 over x1 equal y2 over x2. So we can take this as the first equation when I have quantities that are varying directly with each other. Okay, let's take an example to see how we solve or how we apply those proportions. So if y varies directly as x, this means that I can directly write y equal to k times x, or y over x equal to k. Now, so y varies directly as x, I stopped here. From this piece of information, I wrote this. Now, y equal 15 when x equal minus 5. This is the first set of values. Find y when x equals 7, and here is the second set of values. So this is the first set, and this is the second set. So to differentiate between them, I will give them subscripts. This is y1, x1, and this is y2, x2. Okay? Y1 varies directly with x1, y2 also varies directly with x2. So from this I can say that y2 over x2, or y1, to start with y2, y1 over x1 is equal to y2 over x2. This is the relation we got from here. Okay, so y1 over x1 equal y2 over x2. What do I have given? I have y1, I have x1, and I have x2. I replace all the values and I solve for y2. Okay, so let's do it. y1, 15, over x1 is minus 5, equal y2 is unknown, that's what I'm looking for, and x2 is 7. Now, how do you solve for y2? Of course, we cross multiply, so minus 5 times y2 is minus 5 y2 equal 15 times 7 is 105. So over minus 5, those minus 5s cancel out, and I'm left with y2, which is equal to 105 over negative 5. This is negative 21. Okay, so this is the answer, when x equals 7, because the question is here, find y2 when x equals 7. So when x equals 7, y is equal to minus 21. And this is my answer. Okay? All right, let's continue with joint variation. Another type of variation is joint variation. Joint variation occurs when one quantity varies directly as the product of two or more other quantities. Okay, so we could have like y varying jointly with x and z, okay, or with x, z, and t. All right, so two or more quantities, it doesn't matter. So if we are saying if y varies jointly as x and z, then we can write y equal k times x times z, or if you divide here by, let me change the color of this pen, over xz over xz, those cancel out and I will get y over x times z equals to k. Again, k is called the constant of variation. Now, if I have that y varies jointly as x and z, and I have two set of values, y1, x1, z1, and y2, x2, z2, they are varying jointly with each other, then I write y1 over x1, z1 equal to k from this, as we did here. And from this equation, the same way, y2 over x2, z2 equal to k. This is equal to k, and this equal to k, so I can write y1 over x1 z1 equal y2 over x2 z2. The most important thing here is to remember that when I have a joint variation, then I have to write those variables. Let's say A is varying jointly with B and C. So how do I write this? I write A equal to K times B times C, or A over BC equal to K. Okay? Because we are not going to use XYZ all the time. The variables, the name of the variables change from one question to another. Okay, so let's take an example about joint variation. What do we have here? All right, so suppose y varies jointly as x and z. So I will stop here and I write directly y equal k, the constant, don't forget the constant of variation, times x times z, or y over xz equal to k. Now, find y when x equal 9 and z equal 2. This is the first set of values. If y equal 20 when when z equal 3 and x equal to 5. This is the second set of values. Okay, so from this I build up my proportion or my ratios. So again, I will call them y1, x1, z1, y2, z2, and x2. If you notice here, that the variable I'm looking for is y1. Okay? So I write, just follow this, take it two times, y1, x1, z1, another time y2, x2, z2. So I would have, every time I'm starting with 2, y1 over x1 times z1 equal y2 over x2 times z2. Once you build this proportion, everything else would be zero, would be easy. You just replace the values and you solve for the unknown. Okay, let's do it. So from here we say y1 is the unknown I'm looking for, over x1 is 9 times z1 is 2, y2 is 20, x2 is 5, and z2 is 3. Okay, so let's find the products first. y2 over 9 times 2 is 18, 20 over 5 times 3 is 15. Again here, cross multiply. What do we get? Let me go up here. y2 times 15, which is 15 y2, equal 20 times 18. Okay, so 15y2 is equal to 20 times 18 is 360 over 15 over 15. The 15 here cancel out, and I would get y2 equal to 24. So I would say here, I would answer the question, find y1 when x1 equal 9 and z1 equal 2. So when x1 is equal to 9 and z, or without the 1 here, I can remove the 1. When x equal 9 and z equal 2, we have, or we get the value of y to be 24. Okay? All right. Let me check how long this video. All right, let's continue with the other two. I prefer to make it in one video instead of two. All right, so here with guided practice, this is practice for you. You do it alone. You have the answers here. 30 and 28. This is the answer for the first one, and 28 is for the other one. You try to do them as practice alone at home. Okay, we have another two types of variation: inverse variation and combined variation. After we discussed the direct variation and the joint variation, now it's time to talk about the other two, which are inverse and combined variation. All right, let's start with the inverse variation. If y varies inversely as x, then we can write y equal k over x, or if you cross multiply, this is over 1, cross multiply, you would get y times x equal to k. Varying inversely means if one increases, the other decreases, and if x decreases, y increases. K here is still called the same name, constant of variation. All right, so again, if I have two sets of values, and one value is varying inversely with respect to the other, so I can say that y1 over, or y1 equal k over x1. From this I write k equal x1 y1, x1 y1 equal k. The same thing for x2 y2 equal to k. Because both of them are equal to k, then I say x1 y1 equal x2 y2. Or I can turn this into a fraction or ratio or proportion, whatever you like. x1 over y2 equal x2 over y1. Because you see it as if I cross multiply again, I would get this equation back. Okay, we can keep it this way for inverse variation. Let's take example. If a varies inversely as b, and so a varies inversely as b, so a is equal to k inverse, yani it has to be in the denominator. Okay, so AB equal to k, and because I have two sets of values, I would use A1 B1 and A2 B2. Okay, and this, or from this I can write A1 B1 is equal to A2 B2, as we saw here. Here I have x1 y1, x2 y2. In this example I have a1 b1, a2 b2. So once I set up my equation, I can solve for any variable. a1 28, replace 28 times b1 is minus 2 equal a2 is unknown, so I just keep it a2, and b2 is minus 10. So 28 times minus 2, this would be negative 56. and a2 times minus 10, so this would be minus 10 a2. So to find a2, what do we do here? We divide by negative 10 here and negative 10 here. Those cancel out, and minus 56, or minus with minus also cancel out, and this would be 56 over 10 equal a2. Simplify this by 2, 28 by 2, 5 equal a2. So a2 is equal to 28 over 5. You can write a2 as a decimal, but just to tell you about the problem in the practice, in the Magro-Hill platform, that if you write it as a decimal, it will consider it as wrong. Okay, so but it's fine if you write as a decimal. Now 28 over 5 is 5.6. Okay, so again we say when b2 is equal to 10, or when b equal to, negative 10, we have a is equal to 5.6. This is point. Okay. As for the last type of variations, the combined variation. A combined variation occurs when one quantity varies directly and or inversely as two or more other quantities. Okay. I will just discuss the example. Maybe it becomes more clear. Here I have f varies directly as g. From this, I can say that f is equal to k times g, using our knowledge with direct variation, right? And f varies inversely as h. In the same equation, inverse means it has to go in the denominator. So f is equal to the same f. It varies directly with g and inversely with the h. Okay, so h has to go in the denominator. So this is the equation that relates the variables that I have, the f, the g, and the h. Again, because g is, or f varies directly with g is up, and inversely with h, so h is in the denominator. And again, I would have two sets of values, f1, h1, g1, and h2, f2. Sorry, g1, f1, h1, and this is g2, h2, f2. And what I'm looking for here is g1. Now, how can I form the set my proportion equation? You just take this equation, or you find k from this equation. From this equation, k, if I cross multiply, I would have k times g equal f times h. So divide by g. So k is equal to f times h over g. So the two proportions should be like this one. f1 times h1 over g1 equal f2 times h2 over g2. And now we replace the values that we have here. f1 is 18 times h1 minus 3 over g1 is my unknown equal f2 2 times, f2 is 6 times h2 is 2 and g2 is 24. Okay, so let me just make this a little bit smaller to continue on the same page. So from here I would continue over here. 18 times minus 3, this is minus 54 over g1 equals 6 times 2 is 12 over 24. Okay, so cross multiply, So 12G1 is equal to minus 54 times 24. This is minus 1296. So over 12, and G1 is equal to minus 108. Okay, so when F1 equal 18 and H, or when F equal 18 and H equal negative 3, G is equal to minus 108. Okay, and the last thing here, again, guide the practice. Two examples, one on inverse variation and another one on combined variation. Try to solve them again by yourselves. And thank you very much.